All right, so here we are on the first problem of the Chapter 8 guided problems, and we're told to construct a 99% confidence interval. So I'm going to show you how to use the confidence.norm function. So we just do equals confidence dot norm. I can't make a good dot, N-O-R-M. And the first thing we do is our alpha. Remember, alpha is the same as 1 minus our confidence interval. So if our confidence interval is 0.99, then our alpha is 0.01. Our standard deviation is given to us right here as 12. And it says size, which is our n. That's our sample size. So that's 45. So when I hit enter, what it's going to return is the margin of error. And then we know, so I'm just going to call this margin of error. And we know that if we take our upper confidence limit, well, let's do our mean. Our x bar, our mean, is given to us right here is 47. So our upper confidence limit is going to be our mean plus our margin of error. Our lower confidence limit is going to be our mean minus our margin of error. Oops, all right. So then Excel, or the problem, tells us to round to 2 decimal places. So lower limit of 42.39, upper limit of 51.61. All right. That's it for question number 1. So question 2 asks us to determine the margin of error. Gives us for a 90% confidence interval. Gives us says to estimate the population mean with a standard deviation of 52, and then it gives us 3 different sample sizes, and it's asking us for the margin of error. So remember, like from the last problem, we calculated margin of error by using the I just forget the name of the function, by using the confidence.norm function. Our alpha, remember alpha is 1 minus the margin of error, so in this case it's 0.1. Our standard deviation, which is given to us as 52. And then our size, or our n, which is 39 in this case. So the answer is 13.69. No, 13.70. Sometimes it's nice to let Excel do the rounding for you. Keeps you from making silly errors. Now we could do each of these by just going into here and changing n to that number, like 49. And that gives us the new one. We could also, if we wanted to, set up our own little calculator where we just type in our n, and then here we could tell Excel that this is B2. So now it won't work until we put in, like the first one was 39, and then it will calculate for us 13.7. The second one is 49. Our answer is 12.22. And then the third one is 67. It's 10.45. I think a key takeaway of this problem is that as your sample size increases, your margin of error decreases. In other words, you're going to have more certainty about the range that your number is going to fall in. That range will be narrower as you increase your sample size. And that does it for question 2. So question 3 is similar to question 1, except now we don't know the population standard deviation. So it tells us to construct a 95% confidence interval to estimate the population mean using the data below. and then it asks us what assumptions have to be made. So because we don't know the population standard deviation, but we do know the sample standard deviation, S, then we can approximate instead of using the normal curve, we can approximate using the student's t-distribution, which, if you remember from earlier, is a wider, flatter distribution, which is going to give us a larger confidence limit than if we knew the population standard deviation and could use the normal curve. So to find our margin of error, we're going to do confidence. But instead of confidence.norm, we're going to use confidence.t. So give us a confidence interval using the student's t-distribution. Our alpha, remember, is 1 minus our confidence interval. So in this case, it's going to be 0.05. Our standard deviation, we're going to use the sample standard deviation of 9.4 to approximate the population standard deviation. And because all we can do is approximate the populations, that's why we have to use the student's t-distribution, the broader distribution, to work in more error to our estimate here. And size is our n, so n is 27. It's the population size. That gives us our margin of error. Our x bar, or our mean, in this case is 31. So our upper confidence limit is going to equal the mean plus the margin of error. And our lower confidence limit is going to equal our mean minus margin of error. The lower limit, 27.28, and upper limit of 34.72. And then it says, what assumption do we need to make about the population? This can confuse people because they think that you have to assume that the population follows the student's t-distribution, but actually that's not true. We're assuming that the population it follows the normal distribution, or is normally distributed. We're only using the t-distribution to give us a wider, broader distribution so that we can account for the error in estimating our population standard deviation using the sample standard deviation. I'm sure that was completely clear, but that's what we're doing. So let me check the answer, and we're good. So we'll move on to question 4. All right, so here is question number 4. Now we're getting into dealing with proportions, and they want us to determine the margin of error for a 95% confidence interval to estimate the population proportion with a sample proportion equal to 0.6. So we know what the sample proportion is. We need to estimate a margin of error for if we're going to estimate the population proportion. And then it gives us 3 different problems, in essence 3 different sample sizes. So again, they want us to compare sample sizes. So the first thing that we have to do when we're dealing with a proportion, well, sometimes you have to figure out your sample proportion, but it's given to us here as 0.6. So the next thing you need to do is figure out your standard error of the proportion. Actually, it's going to be an approximate. And the reason it's an approximate is because we don't know the population proportion, so we just know the sample proportion. Anyway, all right. So the way we find this is to take the square root of the sample proportion times 1 minus the sample proportion over n. And you can find that formula on page 355 of your textbook. So I'm going to say this equals square root of, in fact, you know what, before I even do that, I'm going to go ahead and put my sample proportion up here. That's called bar P, and it's 0.6. That will help me a lot. Then I'm also going to put my n in here. And n right now, we'll have n, these 3 different versions of n, so I'll just start with 125. All right. So this is going to equal the square root of bar P minus 1 minus, I'm sorry, not minus, times All right, so the square root of bar p, I know I'm confusing, huh? Times 1 minus bar p divided by n. There's our approximate standard error of the proportion. Once we have that, then we can calculate the margin of error. And so the margin of error of the proportion, well, we need a couple other things. So the first thing we need to know is our critical z for our margin of error. And because this is two-tailed in nature, we're going to have to do our critical z divided by 2. I know that's confusing. So if I have a 95% confidence interval, that gives us an alpha of 0.05, and then the alpha divided by 2 is 0.025. And I can use a calculator, or I can have done this a long time, and I know that that is going to be 1.96. So I'm going to call this my z-score, my z of the alpha divided by 2. Again, you can find these formulas page 356. So now to find our margin of error, we just take our standard error of the proportion times our z alpha divided by 2. And I think this one wants us to do 3 decimal places. So that's going to be 0.086. Then for n is 220, I can just come up here and change n, because now all my formulas are good. So my margin of error is 0.065. And then when n is 260, our margin of error is 0.060. So same idea, we can see that our margin of error decreases as our sample size increases. So question 5 has us estimating the sample size we need in order to estimate our population proportion. And so if you think of the formulas we just used in question 4, we can set them up algebraically to solve for n, because n was part of our formula. So what we need to do is we need our z alpha divided by 2. And so for this one, if we're given a 90% confidence interval, that means our alpha is 0.1 and our alpha divided by 2 is 0.05. And so the z-score of 0.05 is 1.64. If we don't know that, we can use a function in Excel to figure that out. It's norm.s.dist. I'm sorry, it's norm.s.inverse. Sorry about that. And then we put our probability. So if and it's always going to return it as a negative, and that's another whole conversation. But so if my confidence interval is 90%, my alpha then is 0.1, and my alpha divided by 2 is 0.05. So I actually tell Excel to return me the to return this to me as the absolute value. The reason it returns it as a negative is because the z-score of a 0.05 is always going to be to the left of the mean, which would be negative. Anyway, so there's our z alpha divided by 2. It's 1.64. But over time, you just get to learn these. These are standard ones. So a 90% confidence interval that's two-tailed is a 1.64 z-score. Anyway, so don't worry if it's still confusing to you. We also need our bar p, which is given to us as 0.63. And then we need our margin of error. I'm just going to call it ME, which is 0.04. So once we have those, we can solve for them. The formula is on page 363 in the textbook, and I'll show it to you right here. So to solve for n, so that's what it's asking for, is what is our sample size, and the math's a little confusing here, okay? But our formula is our z alpha divided by 2. So z alpha divided by 2 squared times our bar p times 1 minus bar p. So I need to do another set of parentheses to show that this is all the numerator of this problem. And we divide that by our margin of error squared. Again, formula's in the book. You don't have to memorize it. That's going to give us our n, our sample size. This tells us to round up to the nearest integer. So rounding up would be 395. And that's it for number 5. So the last question's a little tougher than the others, and I know that the others weren't super easy, so hopefully it won't be too bad. So now we're supposed to construct a 90% confidence interval to estimate a population mean using the data below. And what we have going on here is that we have a sample size that is within, in this case, our sample size, if our sample size is greater than 5% of our population, then we have to use something called a finite population correction factor. In essence, what this does is it says we're going to have additional error introduced in this because our population is so small. And so again, the formulas for these are on 366 and 367 in the textbook. So let's just kind of start with the data we have. So we have x bar, which, if you remember, is the sample mean. And then we have the population standard deviation. It's given to us, they give us a sigma there of 15. N, which is the sample size, which is 40, and big N, which is the population size of 400. So to figure this out, we're going to need our z of the alpha divided by 2. Remember that our alpha in this case, if our confidence interval is 0.9, our alpha is 0.1. So divided by 2 is 0.05. So the z of that is 1.64. We're also going to need our sample standard deviation, which we can figure out because we know our population standard deviation. So our sample standard deviation is going to be the same as our population standard deviation divided by the square root of n, little n. So this is the sample size. So there's our sample standard deviation. We're also going to need our finite population correction factor. It's not a facto, it's a factor. So we find that by finding the square root of the population size, so big N, minus the sample size, little n, divided by population size, big N, minus 1. So our finite population correction factor will be 0.95. And remember that as a correction factor to help us deal with the fact that we have such a small population. All right, so now we can find our margin of error. which is going to equal our z alpha divided by 2 times our sample standard deviation times our finite population correction factor. And then our upper confidence limit would be our mean plus our margin of error. And our lower confidence limit would be our mean minus our margin of error. And 93.69. Whoops, looks like I did something wrong in my math, so let's take a second and figure out what our error was. So the only thing I could see is I did my z alpha, I just did 1.64. I took it out to further decimals and it slightly changed our answer, so let's see if that was it or if I've got some other kind of problem, because normally this is set up with some tolerances that just being off by 0.02 because of the decimal rounding wouldn't get us. So let me check my answer again, and that was it. So I guess we need to take our z alpha out more decimal places. What I did is I just went back and calculated it by doing norm.s.inverse and put in 0.95. Anyway, so that concludes the Chapter 8 Guide to Problems. I know this was a long one, so good luck, and if you need me, don't be afraid to call.